Welcome. In this video, we will take a look at graphing some more sinusoid functions. We'll look at the concept of the phase shift here and then kind of put together all of the different components as we go through a few more examples. I want to take a short while to talk about this phase shift idea with the function sine of x plus pi over 2. If I wanted to graph this over the interval negative pi over 2 to 3 pi over 2, I can first just consider a table just to get comfortable with where this function is going to be at these points. So I have a table here on the right side that gives us the functional value at each of these points every pi halves as we go through this interval. And so let's just plot some of these points down and then get a feel for kind of the shape of a graph and kind of an overall shifting that happens when we have x plus pi over 2. So at negative pi over 2, we know that this sine function is going to be 0. Sine of 0 is 0. So we would place our functional value down at the y-axis, or the x-axis, excuse me. There we go. At x equals 0, this function is going to lead us to sine of pi over 2, which is 1. That would be up here. Next, we'll be going back down to 0 when we hit pi halves. And then we'll come down all the way to negative 1 when we hit pi units. So that'll be down here, and then we'll complete the cycle at 3 pi halves where we bring it back up to 0. So this would be our full sine wave over this interval using these points. I'm just going to draw this in, and then we'll try to make some observations about the adjustment that this made. If I was to plot a regular sine curve, just the regular sine curve on this graph in red, the sine curve always starts at 0. This is the sine of x. Starts at 0, hits a peak at pi halves, would be back down at pi, hits at minimum at 3 pi halves, and then back up at, we'll call this 2 pi. So if we graph this sine of x, we'll notice kind of the shifting that happened here. Whenever we add some component inside our sine function, we are really shifting to the left. So when we look at our construction of our sine wave or our cosine wave, this is really getting at the c over b value that we're working with. And so this will kind of lead us to looking at the definition for the sinusoids when we have all these components a, b, and c and d in play. So notice that this gives us a shift of pi over 2 to the left. So let's consider kind of the 4 components, a, b, and c, that will transform a sine or cosine function here. So the first thing is a is our amplitude. We've seen this before. The period is always going to be 2 pi over b. And then our phase shift is going to be negative c over b. And so one way we can actually highlight this a little bit more is if we direct our attention to the sine function, we can rewrite this in a factored form. And I encourage you to do this every time that we look at a function. Y is equal to a sine of, we'll factor this b out and call this an x plus c over b, and then plus d on the outside. So when I consider this phase shift, notice that I kind of went in the left direction, pi over 2 here. And so I will always go negative c over b units when I do a phase shift one way or the other. And again, d here translates us up and down, and we'll take a look at that in some future problems as well. But it's a good idea to always get this in factored form. And so we can highlight the exact period and the phase shift really easily from this vantage point. So we'll take a look at one example here in this video of working with a phase shift. So we'd like to graph the function y is equal to 3 times sine of 2x plus, minus pi over 2. So the first thing I'm going to look to do here is to actually factor this so that I have the b and the c over b component. So I can rewrite this in a factored form. This will be y is equal to the 3 as our amplitude. We have sine of, I'll factor the 2 out here, and we'll be left with x minus, if I factor a 2, I'm really dividing both of these terms by 2. So if I divide pi over 2 by 2, I'm going to get pi over 4. So you can consider, if you distributed the 2 back, you should get to the original that we had in our problem. So this highlights kind of all the components I'm going to need to fill in this table and therefore help me with the graph. So first thing is the A amplitude is going to be the absolute value of A, which is 3. The absolute value of 3 is just going to give us 3. The period is always going to be P is equal to 2 pi over B. And so in this case, the B value is the 2. And so when I write this as 2 pi over 2, my period is going to be pi units. So that means I'm going to do a full cycle in pi units, or another way to think about this is B is the number of cycles in 2 pi. So we're going to do 2 full cycles in 2 pi and 1 cycle in pi units. The next thing is the phase shift. So the phase shift is always negative c over b. So this is our phase shift. And so we will say that this is a phase shift of positive pi over 4. Because notice that the phase shift is always going to be the negative c over b, which is right now negative pi over 4. So this, in other words, would be pi over 4 to the right. We're going pi over 4 to the right. And then finally, the vertical shift, there's no d value out here. It would be just 0. And so we'd have a vertical shift of 0. So let's consider how we take all this information and graph. So I'm going to start by just highlighting the amplitude. I know I'm going to set that, and that's not going to change. And then I'm going to consider where I'm going to start my graph, and then where I'm going to finish my graph, and then we'll figure out the inside of the graph from there. So here I'm going to set my amplitude. That would be 3 and negative 3. The next thing I'm going to do is just set where my graph is going to start. That's going to be at the phase shift. So I've got this amplitude. I'm going to now look at the phase shift. The The phase shift says I'm going to start my graph pi over 4 to the right, or really at pi over 4. The next thing I'm going to consider, now that I got my phase shift going on, is my period. So from this starting point, pi over 4, I know I'm going to do a full cycle in pi units. So I'm going to consider pi units somewhere added to this. So I'm going to add some pi units, and I'm going to create a graph within this range. So to do that, I'm going to continue to work out, we'll just call this 2 pi fourths, 3 pi fourths. We'll give this as pi, and then we'll have another one, 5 pi over 4. And so let me clean this up just a little bit. This interval here is going to be pi units long. If we go from pi fourths all the way to 5 pi fourths. And this is going to be one cycle of my graph. So now let's consider, notice that I kind of chunked this up into 4 segments. And that's kind of important when we go to graph these. It's helpful to take our period and chunk it up into 4 sections, because there's really going to be 4 kind of wave portions for our sine or our cosine function. So another key item that we're going to want to think about is that the sine function always starts at the midline. So we can always think sine always starts at the midline. The cosine is at the amplitude. And just to check this for our starting point one time, we can just do a test point here to see where we start, if you wanted to. So if we go over and say 3 sine of 2 times, if I wanted to test my starting point, that would be pi fourths minus pi over 2. I want to test out kind of what this would give me as a functional value. This would be 3 sine. This is 2 pi fourths minus pi fourths. That would be really just a 0 inside the sine function. And we know that sine of 0 is always going to give 0. So at x equals pi over 4, we're going to be equal to 0. So when I consider the shape of this graph, sine functions always shape the same. Start at pi over 4. We'll go and reach our peak at 3. Back down at 3 pi fourths. Hit our minimum at pi. And then back up at 3 pi or 5 pi over 4. And then we'll finish up our curve. Just connect the points. And there we can be able to put this into our Moore system with this graph. So again, to kind of walk through those steps again, I'll always want to set my amplitude first, consider what my phase shift is so I can get my starting point, and then consider my period, and then split that up into kind of 4 segments, and then draw my single cycle of sine or cosine. In this case, I did a sine function. So hope this is helpful walking through this. We'll take a look at another video where we're going to do a few more examples with these phase shift sinusoid functions. Thanks for watching.